The requested example is about driving over a hill and the acceleration, and let's see if we can learn the forces also. So I've set up the car on a hill, so the road presumably continues like this, but the hill itself has a certain radius of curvature. Now, when the car is at the top of the hill, you're going to have, as the forces acting on the car, the force of gravity, which our book calls the weight, W. I always call it F sub g. It's also equal to mg. And then we're also going to have the normal force. So when we set up Newton's second law, F net is equal to ma, vectors, we say that we're doing y components, and we get F normal minus mg is equal to minus mv squared over r. So this a is v squared over r because it's centripetal force or centripetal acceleration, and it is downward. So when I plug it in as an acceleration, it goes in with a minus sign. So then the normal force is equal to mg minus mv squared over r, or m times g minus v squared over r. So if you were in this vehicle and you only took a brief observation at the very top, you would be able to detect the normal force because you would feel how much your guts are getting compressed and stuff like that. And you could probably detect the velocity. We're going to assume you can measure that. There's a speedometer at the car. But the person in the vehicle can't tell if it's different because the acceleration due to gravity, g, changed, or there's acceleration. And that is the entire basis of Einstein's general theory of relativity, and being able to come up with a mathematical system that can account for that, and taking that mathematical system to its logical conclusion is the genius of what took Einstein, I believe, something like 11 years to put together. So anyway, for us, if you have this car going over the hill, one of the main things here is what is the acceleration? And the acceleration is definitely v squared over r. What is the normal force? Here is a perfectly reasonable way of finding the normal force. You should definitely do it by doing a force diagram first and then solving for the normal force. And one of the questions on exam 2 is note that Fn must be upward, which means as a variable, Fn vector must be upward, which means as a variable, Fn must be positive. So that means that mg has to be greater than mv squared over r. Otherwise, this thing on the right-hand side would turn negative, which means G has to be greater than V squared over R, which means GR has to be greater than V squared. So it gives you a max speed that you can travel that usually when we write inequalities, we write them with a less than sign, not a greater than sign. So we could write this as V squared is less than GR. So the max speed is the square root of GR. And that's another consequence that comes out of driving over a hill.